present my thesis on digital twin for existing buildings. This research was conducted under the supervision of Professor Helder Sousa and a tutor from the company Grupo Casais, namely Sergio Laranjeira from Braga. This presentation starts with an introduction to the research question and the objectives. I will then give a little overview about digital twins, like in general, what it includes, like definition, benefits, workflow. And next, I will discuss how to integrate digital twins into projects and address related challenges with an organizational approach. And I will review alternative methodologies, followed by a detailed look at research framework. I will then conclude with some key findings and future perspectives. So my study provides a theoretical foundation about digital twins and evaluates the latest technologies and methods in a digital twin creation, comparing different solutions. So it proposes a framework for digital twins with no BIM model that exists and address therefore challenges and provides recommendations, especially for organizations, how to develop them effectively in the building operation and maintenance phase, as this about existing buildings. And then at the end, with a framework that I apply on the company, namely Grupo Casais, that this dissertation has a collaboration with, exposing the value of the framework. So I started thinking about the term digital twin, and this term is still evolving across the industries. So I analyzed 20 definitions. I identified recurring terms, developed a core definition, and made a diagram which shows the most frequent keywords across these definitions, providing insight in how digital twins are interpreted differently in academia, industry over time, from various sources in the AECO industry. But to create a successful digital twin, certain elements are crucial, especially those who contribute to the high effectiveness of a digital twin. So here you see like this 7 elements, therefore, but not only high effectiveness is important, but we need to know what the main things are of a digital twin in order to function as a digital twin. So therefore, I deconstructed my digital twin into layers by capabilities. So in order to function as a digital twin, it needs, for instance, sensor capabilities, communication capabilities, analytics capabilities. So this deconstruction gives a better insight into the core of a definition, core of a digital twin, and gives a better view on how to understand and tackle the main research question. Before I go into the challenges, it's also important to stand still on the benefits, because digital twins allow for real-time adjustments and enhanced decision-making. But although the digital twin is recognized for its positive impact on the entire life cycle, for me, in this thesis, the operation and maintenance phase is the focus. So this is where I also show you the benefits about the operation and maintenance phase. So by integrating real-time data, digital twins improve facility management, predictive maintenance, proactive management, through, for example, systems like COBE or FMIS. To address the general, it's important to address the general workflow before mentioning, before describing, in fact, a new workflow that tackles the challenges. There are different approaches on creating a digital twin. Therefore, I wanted to mention 2 approaches that I encountered the most in literature research. One approach focuses on efficiency, and the lift one, using existing data to meet clear organizational goals. And then the other emphasis a sequential process from data collection to analyzing action, aiming for continuous optimization. But in fact, what is the thing that is most important to remember, and what I worked further with in my thesis, is that both approaches highlight the need to define the purpose and the goals of the digital twin. A good approach to creating a digital twin from an organizational perspective involves several steps. If you're a company, if your company is interested in designing, building, developing a digital twin, the first and most crucial step is to define the applications for the digital twin. It can serve many purposes, so it's essential to clearly define its intended use. And when the purpose of a digital twin is established, you can then choose the appropriate technology to support it, identify the type of data, and consider extra factors. So the challenges that remain in creating digital twins for existing building, especially with no 3D model, it is that it is expensive, time consuming, and additionally there's a lot of information accessibility problems, and also the lack of open source platforms that hinder optimization. So therefore, a comprehensive action plan is really needed to integrate digital twins effectively, addressing cost, techniques, and required persons. So in this slide, I include, in fact, 3 case studies representing alternative technologies and methods used to tackle the challenges as I showed you in the previous slides. And followed on this case studies, then you have down here in the slide 2 other graphs that have been produced, combining or providing extra solutions on those challenges. So this literature research part forms, in fact, a base for a part of the framework that is developed in chapter 4. So starting with chapter 4, literature research emphasizes the necessity for companies to recognize the resources needed for creating a digital twin, along with goals behind its development. So 4 crucial elements in this process are techniques, goals, requirements, and the level of development. A level of detail. When developing a digital twin for buildings without an as-built BIM model, it's essential to address these elements. The LOD helps identifying various types of digital twin achievable through different techniques, which were sourced from both the collaborating company and the existing methodologies as showed in the slide before. And then the requirements are the conditions necessary for the desired digital twin type, while the objectives specify what needs to be accomplished, both based on common elements from the literature. So, so what I want to say is that you will see in the next slide the interconnection between these 4 elements. And these are based on the literature review using bar charts that represent the ratios. So there are every time 2 types of bar charts, one showing the importance of one element across different categories, and another comparing sub-elements within a category. So this bar chart shows that LiDAR cameras and 3D laser scanners are more crucial for LOD 100 compared to CCRS and IoT sensors. So this is the connection made between element of level of detail and techniques. So as I said before, we have 2 types of graphs. We have the one showing a sum up to 100% and one without. And this dual view provides multiple insights. So if I go to the next connection, but then between level of detail and requirements, there's every time for each relationship, there is a common factor that is the bridge between those elements. Such as for LOD and techniques earlier, it was the key components that makes the bridge between those that made it possible to make this chart, as it is a common factor for both, as it's both important for the high effectiveness of a digital twin. So every time there's one factor that bases between those elements. So here you see again two charts every time, one summing up to hundreds, another not. For example, giving insights as IoT sensor excel in real-time data collection, while 360 cameras and LiDAR are better for AR, VR applications. While in the other one, with the same relation, you see if data storage has 13% of the total importance, which is the highest percentage of that techniques, it is the most important. And same for techniques and objectives. So now the foundation has been laid, the flow chart can arise. It consists in fact of two parts. So the first helps identifying achievable levels of detail based on the techniques available to the company for developing a digital twin. And then we have an intermediate step, which is not part of the flow chart, but it includes scenarios based on the level of detail classified as A, B, C until G. And this scenario assists the company in aligning techniques, requirements, objectives, and resource allocation. If the level of detail does not meet project needs, investment in techniques for a higher level may be necessary. So these scenarios guide, in fact, through making informed decisions throughout the project. So by knowing the level of detail that can be achieved, we can go to the second part of the flowchart, providing the methods that can be followed and the outputs of digital twin that can be obtained. By examining specific levels of detail, the most relevant objectives and requirements were identified for each technique. So here I work from a dual perspective, ensuring that when requirements and objectives align with both the chosen level of detail and techniques, they form the core components of that scenario. So every scenario starts from this level of detail, 100, and the techniques, and but it also has the objectives and the requirements for showing for every technique, as well as what I show in the next page, the resource allocations, which includes for every scenario people, budget, and time. This is a summary table from which the calculations are done in the end of my thesis in the appendix. So this is just a representation, makes it easy for companies to gain a general basic idea. But it's important that you are aware that it's not about accurate budgeting values, but it's a potential basic idea that I want to give here, because it all depends on, well, the time and cost can vary widely based on project scope, complexity, location, labor costs, time, and markets. The scenarios clarify which level of detail aligns with project requirements, objectives, and resource allocation. So this part of this flowchart also indicates digital twin projects maturity, digital model, the digital shadow, and digital twin. So after selecting the level of detail from the scenarios, company can choose then from here, level of detail 100, as in the example of the slide, okay, path 1, it's focused on image-based techniques, path 2 is remote sensing techniques, path 3, a combination of both, and so you obtain the digital twin with what you have available. So for me, it was also important to compare the source allocations, especially about price and time. So what you can analyze from the left graph is that scenario C presents a more cost-effective option for smaller firms compared to lower detail levels, so level 100 and 200, especially when investment in techniques is necessary. While developing the digital twin generally increases costs, scenario E is unexpectedly more expensive than scenario F. which you see on the right, by the way. So scenario F offers a higher level of detail at a lower price. So both time and cost data were combined into this graph, which indicates that scenarios B, D, F could be seen as favored in terms of both time and budget. So to align the framework with the needs and goals of the company, I conducted a survey. So a survey, again, based on those 4 elements. So the results indicated that the proposed digital twin aligns closely with scenario G. Key conclusions include that there is no investment needed in new techniques except in CCRS, for example. It aligns perfectly with the objectives and requirements, although there was an uncertainty if it was closer to LOD 400 or closer to LOD 500. But this uncertainty also shows that it's important to have a framework so that there is really a need for it. And another uncertainty was the budget. Sometimes you signed a survey that they were not really sure about the budget, but what came out was here that it's that they range a budget between 3,000 and 8,000, while scenario G is slightly over it. But we can compensate this a bit with re-evaluating the techniques that are part of scenario G and the objectives within the scenario and the requirements within the scenario that they want to achieve. Maybe with a technique that is already inside, they don't need the CCRS investment anymore. So it depends. There's within this scenario, you can analyze and see how you can reduce costs and time. So this research has developed a practical framework for implementing digital twins in existing buildings without an as-built BIM model. So it assists really companies such as Grupo Casais in selecting suitable techniques and level of details, and it's identified with the project's requirements, objectives, how to ultimately saving time and costs. So the framework, in fact, serves as a roadmap for effectively integrating digital twins into workflows, making good informed decisions, such as avoiding necessary investment in techniques. It's very adaptable across various project types and sizes, making it broadly applicable in the industry, but I'm aware that it offers a general overview rather than highly detailed results. So the bar charts are based on ratios derived from the literature review, suggesting that practical experiments could enhance more accuracy, for example, or detail. So, however, each level has specific objectives and requirements that vary in importance. So this research contributes on the one hand to the practical application, making it valuable for industry professionals, and it contributes on the other hand to the theoretical understanding of digital twins and leaving an opening for further detailed research into a specific aspect of the general workflow as a theoretical base to develop a digital twin with the framework in following up theses. So thank you for listening. I'm curious to the questions.